test on chapter 4, the chapter on congruent triangles, right?
Yeah.
When you say the unit test. Okay, so now you're on to perpendiculars and bisectors, that kind of stuff? Properties of triangles? That's what my next chapter in my geometry book says, properties of triangles after the congruent triangles.
Okay.
Do you have some stuff you can send me?
Yep, that's what I'm doing, but
Okay.
my phone's being stupid right now.
Kind of weird. My last student had a problem also, and
No, I just click on things and they don't work, and then I click again and it clicks on the wrong thing.
kind of. My last student, he sent me something and it spit it back saying, cannot send it right now. And then about 30 minutes later, it came through. So sometimes there's just a chink in the internet and it will cause stuff like that.
I sent it.
All right.
Not the best pictures.
How many attachments are there?
What?
How many attachments?
There's two.
Two?
I got 9 problems for homework. That's it.
All right, here it is. Which page do you want to start on? One on the right or the one on the left? If you can see.
Start on the one on the left.
Left?
Right.
Okay.
Yeah, the unit test we had yesterday was super easy.
Oh, good. So you probably did really well on it.
If I did well, it will certainly bring my grade up to an A.
Good. Good.
If I got less than a 90%, I will be surprised.
I actually
and disappointed. Like that.
I will also, because you demonstrated a good understanding of congruent triangles. So I'd be surprised if you got less than a 90. When you're taking these pictures, it looks like you maybe need to back up just a hair when you take them.
Yeah.
Or take them from a horizontal instead of a vertical. You took this vertically with your iPhone?
Yeah, the other one I took horizontally.
Okay. I can always rotate. But you'll notice on this one, I'm missing a little bit of the right side of the page. I'm sure we can probably still do it. Fine. Where do you want to begin?
We have 9 problems tonight. That's it.
Okay, 1 through 9?
So we need to do 1 and then 3, 4, and 5 on this page. And 5, I don't know what happened.
Yeah, I don't have a 5 on this page. Must be to the right of 4. Which looks odd. It doesn't look like it would be to the right of 4. Where is 5? Is it to the right of 4?
Yeah.
Okay.
It's easy though. It's no problem.
All right. So you need to do 1. Is that correct?
Yes.
Okay. So in triangle ABC, D is the midpoint of what? What's the rest of that say? D is the midpoint.
D is the midsegment.
DE is the midsegment?
Yeah, is the midpoint of AB, and E is the midpoint of AC. DE is a midsegment.
DE. Is it horizontal or vertical? Must be Is it the
It's a
horizontal?
line connected between two midpoints of a triangle.
Right, but I could do that in numerous ways. I could do
It's
it
a
like that.
segment
I could do it
A
like that. I
connecting
could do
two.
it like that. All of those are mid-segments. So is it the one that's horizontal, or in other words, D is the midpoint? What's the rest of that sentence say? D is the mid.
Okay, in triangle ABC, D is the midpoint of AB, and E is the midpoint of AC. DE, segment DE is a midpoint of triangle ABC.
That defines it.
That's the answer.
So D is the
So let's move.
midpoint of AB, and E is the midpoint of BC. Is that what it said? So that's the correct picture. DE is a what of triangle ABC? What's the fill in the blank in place of that question mark?
Yeah, it's a mid-segment.
All right. What next? Number 4?
Number 3.
Number 3.
X equals 13.
Okay, mid-segments are always half of their base. And
yep, and then X equals 10.
Okay.
Because since D is a mid-segment, you have to double it.
Uh-huh. Okay.
And then you don't see it, but it's basically a bisector, not a perpendicular bisector, but DE is a bisector of AC. The two sides, the two halves that are created are AC, are AE and CE. One is 6 and the other is X. So I can already tell that X equals 6.
All right. As long as you know how to do it and you're comfortable with it, we don't need to do it. So it's not important that I see it unless you're having problems with it. Okay, let's do this.
So 24. Go to the next paper, though.
Oh, okay. The next problem is the next paper. All right. So you don't have to do 6 through, you don't have to do this 9?
Nope. We literally had 9 problems.
Oh, right. All right, hold on a minute. And I think that would be the next one. Oh, I got it backwards. All right. Here I would have seen 5, kind of. Still wouldn't have been able to read it, but
I'm terrible at taking pictures. I do not have steady hands.
Well, that's part of it, but also part of it is making sure that you have the entire picture in your frame. And the third part of it is always make sure you have good light. I've got a feature on my phone that even if I don't have a steady hand, if I hold the camera clicker down, it takes 5 instant pictures, blends them together, and takes out a lot of the unsteadiness. It's like a motion inhibitor.
Yeah.
If you have something like that, it might be worth using. All right.
I did that with the first one, but I didn't see much difference.
Okay, so 24 is the next one?
Yes.
All right, let me blow it up a little bit here. All right, so AB is that. GJ is 2x plus 24. What is AB equal to? All right, so what can you say? What's the relationship between AB and GJ?
AB and GJ must be 6x minus 10. No, 6x plus 16.
Correct. That's GJ, right? and they're telling you it's 2x plus 24. So how can I take the information they're giving me? In other words, first of all, let's start here. AB is equal to what? 1/2 of GJ, right?
Yeah.
That's where I want to start. Now,
So
AB is 3x
times
plus 8. And they've told us that GJ is 2x plus 24. Now we have an equation that I can solve easily. How do I solve this?
first, what I did is I just did 6x plus 16 equals 2x plus 24.
I like that. Better than distributing the 1/2. Even though it distributes very nicely to that, I still like it better. Get rid of your denominators.
So first I subtracted 16 and got 2x plus 8. 6x equals 2x plus 8. So then I subtracted 2x and got 4x equals 8 divided by 4. X equals 2.
All right. Now,
and then you have to plug that in. So 3 times 2,
yeah.
8. So 6 plus 8 equals 14.
That's what AB is, 14. Now, the next...
How was your Halloween?
What's that?
How was your Halloween, sir?
Well, it was pretty good. I had to cancel a session that somebody scheduled at 7 because all my trick-or-treaters come to my house between 7 and 8. So I had a lot of kids show up. Yeah, I got rid of a lot of candy. Unfortunately, I still have some left. I say unfortunately because I'm trying to cut back on sugar. So
I gave some king-sized candy bars out to kids.
Did you?
Because I could.
You guys have a lot of people, you guys have a lot of people show up in your neighborhood there?
We didn't have too many people.
I bet I had, let me guess, 50 kids come to the house in that hour. And, you know, in
I'm going to guess
groups of 2 to 6.
Yeah, I'm going to guess if we had like 30.
Yeah, yeah. I'm always glad when it's over. My dog kind of goes crazy. My dog barked solid for an hour and a half.
We had to lock our dogs in the laundry room for like 3 hours.
Yeah, that's probably what I should have done. I didn't do that. I'm going to have to remember to do something like that. Halloween and 4th of July. My dog just goes nuts both days.
I love the 4th of July.
Well, it's a nice time of year. I like the summer. All right, so 25, is that on the list?
Yep.
So, how are we going to do 25? 25 is pretty much the same as 24, only a different mid-segment.
So, basically,
I think it's helpful to start where I started before. What's the relation?
yeah, no, by the way, so since we know that HB is the same length as AC, we can divide HJ by 2 and get 3y minus 5 equals 2y plus 1.
All right, I still prefer to start here. That's kind of like the general formula, okay? That's where you want to start all of these problems. You're inclined to do them a little differently, and it's fine. You're going to get the right answer, but you're kind of taking shortcuts. But when the problems get more complicated, you'll need to do it like I'm doing it. Kind of notice what their error analysis, the way they start that off. DE is 1/2 of BC, even though that's not correct looking at the diagram, but that's the way they start the problem off. And that's how you want to start these off. And then you just do substitution. In other words, the next step is 3y minus 5 equals 1/2 of 4y plus 2. And then you can do the same thing you did on the last problem. Get rid of the 1/2. So we have 6y minus 10 equals 4y plus 2. And then it's a piece of cake. You get 2y equal 12, y equals 6. And now plug in y. 6 for y, you get 18 minus 5. Oh, I see. I did something wrong here. They're asking about HB, huh?
Yeah.
Well, HB is the same as AC.
Yep.
HB is not, okay, so HB is 3y minus 5, but you still have to solve for y. So you still kind of have to do this analysis here. I don't think there's a shortcut. Even if in other words, if I start off saying AC equals HB, I don't really have any place to go, do I? In other words, I can plug in 3y minus 5 for AC, but that doesn't solve for anything. So I kind of have to do this intermediate step that I did, I believe, unless I'm not seeing something here. In other words, I need to go through this step such that I can solve for y. And then I need to know that AC is the same as HB. And so if AC comes out to be 13, then HB has to be 13. But I don't think you can solve the whole thing without that. In other words, if you start there, I don't believe you can solve it. How would you solve it if you start there? Couldn't do it. You could
Well, what I did,
y minus 5, but we don't know anything about HB. Ah, you know that HB is half of HJ. So that's what you did.
yeah.
And
So
half
I did 3y minus 5 equals 2y plus 6.
plus 1.
I don't know what I was thinking there.
Okay. And then you get y equals 6. Yeah. And then you can come up with a number for HB and AC. All right. 26?
Wait.
What's the next one to do? The length of HB was 13. It was the same as the length of AC.
Oh. Yeah. Yeah.
26? So here they're telling us that GH is something and BC is something. So let's start with the relationship between GH and BC. Let's do it this time. What's the relationship? GH
well,
equal
GH
to
is 2 times BC.
2 times BC,
GH.
right? Now just plug in the information they've given you. 7, what's wrong with me? I keep trying to write a 7 and it comes out as a Z. Wow. 7z minus 1 equals 2 times 4z minus 3. I wonder if everybody does that. When you're writing 7z, if the tendency is to make that 7 look like a z. You know what I'm saying? Maybe. And then it becomes pretty easy. Now here, I would not divide everything by 2. I would distribute it. You see why?
Yep.
Because if I divide by 2, I'm going to introduce fractions, and I do not want fractions.
I know, I distributed 2.
Right. And then, of course, you get z over there, and you get 5 over there.
And GH equals 34.
Yeah. Exactly.
Plug them in.
All right.
So 29.
29?
Yep.
Okay. Let me see if I can make these out. Let's see, I got triangle. Those two triangles are congruent. Correct? Okay. That has to be what they mean.
Yep.
And let's see, find the coordinates of the red point in the figure, then show the given statement, show that the given statement is true. All right.
So I know the point that the red point is
I don't care what the answer is. Show me how you got it. What's this point, the vertex there?
that's going to be what? What do you mean?
I can't read it. This
What vertex?
the point right here. What's that point?
That is
What is it?
the coordinates are h. The coordinates are HK. They don't give any actual numbers.
Oh, okay. No wonder I couldn't read it. I was trying to put numbers on it. Okay, and how about the coordinates up here? Is that 2H?
Yeah, that's 2H, 2K.
And finally, the coordinates here must be
2HK.
all right. That's all the information, and then this is 0, 0. And they want the coordinates right there. Well, what's the x coordinate?
The x coordinate is h. Oh, sorry. The x coordinate is 0.
Okay. What's the y coordinate?
That would be just k.
Yeah, that's true only if that's a horizontal line. But we know that it...
We already know. But we already know it's true. From Q to S, there is no incline. And that's all one segment.
Right. Right. So you're saying because we know this is K and this is K, that's a horizontal line and it's not bent right there.
Yeah.
However, could I not draw two congruent triangles that looked like this?
You could, but
Good. And so the question is do we know that that's a straight line, that horizontal line in my first picture? I'm not sure that you do. In other words, couldn't it be broken like a degree and you wouldn't be able to see it in the picture? And that might change the coordinates over here. But when it says show that the given statement is true, I think what we have to do, I see. No, I guess we're doing it properly. I'm probably looking for ghosts when I look at something like that. First of all, if the picture was drawn like that, then these coordinates wouldn't be correct. It wouldn't be h comma k and 2h comma k. Ooh, no. This could be the horizontal line right there, and this could be the line that has some slope on it. Interesting. Well, if you assume that that is a horizontal line, then it really becomes rather easy proving the two triangles are congruent. How would you do that?
Well, number one, with the vertical angles.
Okay, so that's equal to that.
Yeah, RQS have to be congruent to OQP.
Okay.
Then, and then we kind of, do we know this, that they're perpendicular?
I don't think that, okay, so you're going to prove that that's equal to that, and you're going to prove that that is equal to that, correct? And we can do that. We can prove those things.
I can do that.
Right. And no, we don't know that that is a right angle. However, what do we have? We now have side-side angle.
Yeah, but that doesn't prove congruency.
No, I know. That's why I'm a little puzzled. Let me erase that. If we want to, we can prove that this side right here is the same as that side by figuring out its distance using the distance formula.
Yep.
And that may be what we have to do here. In other words, the distance on this lower one is the square root of h squared plus k squared. That's this one here.
Mm-hmm.
And the distance on the upper one is the square root of 2h minus h squared plus 2k minus k squared. Those are the same, therefore it's side, side, side that proves congruency.
I'm gonna do side angle side.
Okay, that also, either one, obviously. A lot of these congruency, there's more than one way to prove it. Especially since once you prove they're congruent, then you know all three sides are equal to one another and all three angles are equal to one another. So you're always going to have a choice with a lot of them. So, all right. Just looking at their error analysis. I'm curious. AD is equal to DB and AE is equal to EC. I guess the reason that's wrong is, and this is kind of insignificant, I didn't realize this. Just because you have a line that is half the length of, in other words, if I make that 4 and make that 8, that does not make that a mid-segment. If I draw a mid-segment, it's going to be 4 for sure, but just to show you, here's the mid-segment, which is 4, is all I got to do is tilt that mid-segment, move the left up, the right down, and it'll still be 4, and it'll still connect with the two sides of that triangle, but it will no longer be a mid-segment. In other words, the line would no longer be parallel to the base. In this drawing, DE is clearly not parallel to BC, and yet it's still equal to half. They tell you that it's equal to half of BC, and it is. That indeed is 5, and that's 10. But that is...
What question are you on?
I was looking at number 27 on this page.
We don't have 27.
No, I know. I thought we were done with all of them. You got another one?
No, we have 30.
Oh, you have to do 30? Okay.
Mm-hmm.
Let's look at 30. So they merely Okay, let me draw 30 here. Whoops. I tell you what I got a lot of in my neighborhood today is I can tell people coming by, political people, to get out the vote.
Yeah.
Seeing people in the neighborhood walking, and my dog's been barking all afternoon also. Coordinates of that point right there, or what?
What? Yeah. Negative 2h 0.
Negative 2h comma 0. Coordinates of the vertex of that triangle is 0 comma 2k.
Yep.
And coordinates over here must be 2h comma 0. And they want the coordinates there and the coordinates there.
Yep.
Okay. Well, if they're telling me that that's equal to that, then what are the coordinates? That's a midpoint of that line. Find the midpoint.
Those coordinates must be h and k.
Negative h and k.
Oh, I didn't know which one you were talking about.
Yeah. And this one over here has to be h and k, based on the midpoint only, not anything else. Okay? And this, what happened to my pen? This line is equal to that. Well, let me close my door. Okay, so we got the coordinates of both of those 2 points. And now our goal is to prove that the slope of these 2 lines are negative of one another.
So we can use this by finding the distance formula, right?
Don't have to do that. Use the slope formula. What's the slope of, here, let me use red here.
Wait.
What's the slope?
I'm just asking something. I'm just gonna ask you something. On the previous question. On the previous question, assuming that that line was horizontal and the other 2 were vertical, as we can obviously tell they were, then we can prove that they were perpendicular due to the fact that their slopes were opposite reciprocals.
Okay, yep. Well, yes and no. The problem with a vertical line is the slope is undefined. So
yes,
it starts getting a little tricky when you use...
Isn't there also like a theorem that states that?
Yeah, if, in other words, the slope of a line that is perpendicular to a undefined slope is 0.
Yeah.
Horizontal line has a slope of 0, vertical line has a slope that's undefined, and they're perpendicular.
What's that? What is that theorem called?
I have no idea. The last thing in the world I ever do is memorize the names of theorems, because that's not what you want to remember. What you want to remember is what it means. Now, I understand that you're taking a geometry class and sometimes they make you tell them the name of the theorem, but as a tutor, it's not something that I keep in my brain. Unless I happen to know, you know, like the alternate interior theorem for parallel lines and transversal, I happen to know that one, but a lot of them I don't know the official name of the theorem because it's not important to me. Okay? Now, on number 30, we don't need to do anything but calculate the slope of the green line and the slope of the red line. What's the slope of the red line?
Well, we're not trying to find the slope of those. We don't need those.
Yes, we
All
are.
we're trying to do is
Look what it wants you to prove. It wants you to prove that the slope of HE is
Oh, no, never mind.
the slope of...
I was reading.
All right. So what's the slope? What's the green slope? Or what's the red slope?
The red slope, that would be 1/3, right?
Well, it's x minus x, so it's 3h divided by the run, excuse me, it's the rise over the run, so hold on a minute.
Yeah.
The rise is k, the run is 3h, so that's the slope. And then if I look at the slope of the green line, the rise is k again, but the run is now 2h minus a minus. You got to go in the same direction. So if I'm going to do k minus 0, I got to do minus h minus 2h, which gives me minus 3h. And now I've proved what they want me to prove. And I don't have, in other words, as long as the red slope is k over 3h and the green slope is k over minus 3h, then that proves that statement there. Now, you'll notice something I almost got tripped up on. You have to go in the same direction. When I did the second one, I started to go in the opposite direction. In other words, I got a rise of k, I can see that. And then when I went to do my run, it looked like 3h was the distance from there to there. But I got to make sure I go the same direction. So if I'm going to do k minus 0 to get a k in the numerator, then I got to do minus h minus 2h in the denominator. I got to go the same way. That's why I get a minus 3h there. You see that? You see how I got that?
Yep.
All right. And that's all that they wanted us to prove, so we're done with that. What else? Any?
Yeah, the slope of, say, d is negative 3h over k, right?
No, it's rise over run.
Oh, never mind.
So it's k over negative 3h. For the green one, and the red one is k over 3h.
Wouldn't it be negative?
No, let's do the red one. If we're going to do k, excuse me, if we're going to go this direction, you can always go any direction, but if I'm going to do k minus 0, then I got to do this part is h minus a minus 2h. So h minus a minus 2h, and that's how I end up getting k over 3h. And then if I'm doing the green line, this time I'm going to go from that one to there, which is k, but then I got to make sure I start there and subtract that. So I got minus h minus 2h. That gives me k over minus 3h, and that's the negative of the other slope, proves the statement. The only mistake you could really make here would be going in the opposite directions, which is relatively easy to make that mistake on this particular problem because they're not using numbers, they're using letters, and we instantly know this height is k, so we know the numerator is k in both instances, and we can almost do that without doing the subtraction. In other words, without saying k minus 0. In other words, it gets us off our pattern, or it gets us the methodology. The methodology is m is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1, or you can switch the top and the bottom. But you can't switch one without switching the other. And it's easy to make that mistake on this particular problem, because we're not really doing y sub 2 minus y sub 1. When we look at it, we're saying, that distance is h, or k rather. I know that that's k, and that's k. So if I just use that logic and make k the numerator, it kind of screws you up, because now you don't know what to do for the run, the denominator. You don't know which way to go, unless you kind of go back and do it exactly the way you're supposed to do it, and then you know which direction you're going. You understand what I'm saying?
Yep.
Okay. It's kind of a bit of an unusual problem that probably only going to come up when they're using letters here. And then it becomes easy to make that mistake. Although certainly if you make that mistake, you end up getting k over 3h and realize, oh, I made a mistake, because clearly these two slopes are not both positive. So you would spot it. I spotted it. When I first did the problem, I was going to make this 3h over here, and I realized, well, that can't be right. And then I realized what I had done. I had just assumed the numerator was k without realizing that I was going from this k minus that. All right, Bolton, what else? Anything?
That's it.
Let's call it a session. And let's see, your brother's going to have his half-hour session today?
Yep.
I will talk to him in 15 minutes.
Good.
Have a good one. Talk to you next week.
Okay, bye.